Alright, so in this presentation I'm going to go over some commercial HVAC equipment. This is by no means comprehensive, but this is meant to summarize a lot of the key pieces of equipment that were in the videos this week. Okay, so first of all, we have a cooling tower. Cooling tower is really common in large commercial buildings, actually in some smaller ones as well. The point of a cooling tower is it uses evaporative cooling to pre-cool water. So there's a video and a reading this week, so I'm not going to go over a whole lot of detail, but basically you have warm or hot water. This is uncommon to have hot water, but you used to have warm water. And really what you do is you have this warm water that comes in a pipe at the top. It's pumped up to the top of a tower. There's a fan that draws air through the tower. It sprays out the water. The fan pulls air through the warm water, causing evaporation to occur. So you'll see some evaporation coming out at the top. And then, of course, as you know, when you evaporate, you pull heat from that substance, and so it cools the water down. The water drips down through gravity, and then it is pumped back after it's cooled down into the building. This will come in many different configurations. A large cooling tower looks something like this. We have this big pipe. This thing could be 2 to 3 stories tall. Giant fan at the top, and this just sprays the water in, and then there's a fan that pulls the air through. There's a couple different models. I'm not worried about whether the fan's blowing air from the side or from the bottom. Just know that it's pulling air across the warm water, which evaporates it and cools it down. All right, you can have a whole series of cooling towers like here on the rooftop of a building. You'll see these in a lot of commercial buildings. And so the point here is that instead of using a chiller or using something that uses a lot of energy to cool down the water, you're just using energy to run the fans, which is a lot less energy than running a chiller. So basically the air, you're using the air as a heat exchanger, kind of grab some free cooling from the air. And that often will be piped into a chiller. And what it does is it basically pre-cools this water. So you can actually see in the image to the left here, you have a cooling tower where the water, you can see the water goes up here and it comes down. So this would be your chiller. Okay, this whole thing is your chiller, excuse me. And so the chiller, all it does, it literally just chills the water, right? So it takes, there's always these two tanks, and you have, it uses a refrigerant. Okay, so it uses a refrigerant to pull heat from the water that comes in. So basically you get water that'll come in. I don't see which pipe. It's probably this one going in here. I'm not sure. So you'd have cool water or even warm water go in, and then there's this compressor which just compresses, uses an evaporator and a condenser, and the condenser, the evaporator's on the chilled water side. Okay, so you have the evaporator on the chilled water side, right? So the water that you want to cool down, you have the evaporator coils there because that's going to pull heat from that water, and then what it does is it takes that heat and it dumps it into that warm water loop here. Okay, so you end up with extra chilled, or not extra chilled, you end up with chilled water on the one side. And that there's 2 loops here, right? So there's 2 loops. There's this chilled water loop, okay, and that's going out to the building. That's the cold water coming from the chiller. And then you have your cooling tower or condensed water loop. There's different names for it, but basically you have the condensing water loop and the chilled water loop. Okay, so that chilled water loop just keeps circulating, right? So you're using this to cool the building, and so it comes in kind of warm, and then it goes into the chiller. It cools down, and it goes out a lot colder, and then goes out to the building, picks up some heat, and that's the whole point. It picks up heat throughout the building, comes back, cools back down, and so on, right? And then the second loop is that the cooling tower loop, right? And so that's the loop where, so what's happening here is you have this chiller, okay, that's taking heat from this chilled water loop, dumping it into this condensed water loop, right? So chilled water over to the cooling tower loop, and then it takes it to the cooling tower, cools it down, comes back in, dumps it in, and that's another loop. Okay, so everything, as I've said before, everything in HVAC's based on these loops, these circuits. And so the chiller has this chilled water loop that it just cools down the water. So a lot of times the water will go out to like cooling coils or an air handling unit. We'll talk about that in a minute. A boiler, pretty straightforward. A boiler heats up water. Okay, usually it's using some sort of hydrocarbon. Gas is really common. Could be oil. Could even be like biofuel or biodiesel. Even wood. I've seen wood boilers as well. And so what this does is, I mean, it's pretty easy. It just boils and heats up the water. And then of course you have your fluid, just like any other boiler. So you can have high efficiency one like this with the PVC pipe. You can have the lower efficiency. There's all just manner. You can have a wall boiler. There's all kinds of stuff. But basically a boiler is just anything that heats up water. And the water, a lot of times it'll go out to an air handler, and it just goes through these coils, and then the fan blows across the coils, and that provides heat to the building. It may go to a heat exchanger. It may be used for domestic hot water. It might go to like a hydronic system, like a baseboard system as well, but a boiler is just a generic term for anything that heats up water, and then you have these circulating pumps that'll send it across the building. So air handling units are really common in commercial buildings. There's, again, just like all these other systems, there's all kinds of different air handling units. This is one that's in the interior of a building. They generally have the relatively same components. You're going to have a return duct. You're going to have a supply duct. You're usually going to have a fresh air duct coming in. You're going to have a filter in there to clean out particulates and clean the air. You're going to have some sort of a fan to blow. That's the whole thing. The air handler is operated by the fan. The fan is the thing that, just like we've talked about before, just like a forced air, it pushes air out and pulls air in at the same time. You may have a heating coil in there, so you may have a hot water coil. Like I said, you just have these basically metal pipes that snake inside, and then the air handler blows the air across and heats it up. You may have chilled water loop in there. You may have an evaporator coils in there as well to cool down the air. So if there's any number, you could have a gas burner in there. So air handler is a generic term. It's a cabinet of some kind. It has an air handler in it, and then you're going to have a filter, and that's going to provide heated and cooled air to the building. So there's a bunch of different configurations for this. Here's just an example of one. You have your return duct, the air is coming in. There's a filter cabinet right here. There's heating and cooling coils in here. I'm not sure what it could be. This could be a hot water loop. It could be a chilled water loop coming in. Here's your fan that's pulling air across this direction. This is a flex connector that helps minimize the sound, the rattling. Right, and then here's your supply in this case. Here's another configuration, a couple of configurations, right? So this is really common to have, excuse me, a return air and an outdoor air duct. And you'd have something here called a mixing box, and that's where the outdoor and the return air mix, right? So again, here's your fan, here's your air handler. It's pulling air through, pushing it out, okay, out to the building. And what a lot of these will have, the modern ones will have dampers on the outdoor air and the return air ducts. So these louvers that can operate and they can open and shut, all right? So like usually they're like this, and then they'll close if you want to minimize your air. So this, if you have sensors here and it's programmed properly, what you can do is you can control the outdoor air that's coming in. This is a really important aspect of ventilation because, again, we've talked about this a number of times. You're bringing in outdoor air, so that's unconditioned air. It could be really hot outside and you're trying to, in the middle of the summer, then you need to cool the air down. Or if it's really cold outside and you need to heat it up, there's an energy penalty for bringing in outside air. So generally speaking, you want to bring in the least amount of outside air that you have to, based on the occupancy, right? So you need to provide fresh air to the people in the room. And so that's where you have these dampers that are operated with these actuators. So the actuator is just a little motor that tells the, physically moves the damper. And there's a sensor on here that's connected to the whole system that says, look, the room is full, the carbon dioxide levels are going up, we need fresh air, and it'll send a signal to this actuator. It'll go whoop and just open up, pull in more outdoor air until that carbon dioxide level goes down to an acceptable level, and then it can close, right? So you can program these to very specific levels, and when you have a system like that, it's called, and you want to jot this down, demand control ventilation. So demand control ventilation is when the system can change the ventilation amount of fresh air, the amount of ventilation based on the occupancy. So you can pre-program it, you can have sensors, there's all different manners of doing this. But the idea behind demand control ventilation is that you want to limit the amount of fresh air that you bring in as much as possible, but you need to provide a minimum amount of fresh air based on the occupancy, and that's something that you'll go over in your lab today, and something that was gone over in your lesson today in a separate video. But all of that is usually taken care of in the air handling unit, so it's a really important part of a lot of HVAC systems. Again, they're not all the same. Sometimes you'll have an air handling unit that just provide heating and sends heat out to these boxes called VAV boxes, that then they sort of distribute it, or the air handler could distribute it right to the room, or it just goes right, one duct goes just splits and is sort of a constant volume. So there's just all kinds of different ways that these are configured. A rooftop unit, again, we've talked about this before, but these are very, very common. Really small footprint. It's heating and cooling all in one. Here's you have your fresh air coming in, right? So these can have dampers on them that you can have. You can modulate the amount of outdoor air you're bringing in. Here's your return air. Here's your supply. You can't see the supply duct that will be coming down. There'll be a filter cabinet here. Here is your mixing box, right? So that's where your outdoor air mixes with your return air. You get a fan. This one has coils, evaporator coils, so this is cooling. There might be a gas burner in here. Sometimes there's heating coils, sometimes there's hot water coils, so it really just depends on the system. There's all kinds of different configurations, and you can sort of see over here, right? So here's your return air coming in, here's your outside air coming in, right? Your fresh air, right? So this is operable dampers. So this is your mixing box, your air handler. So the basic components are generally the same in most package units, although the heating and cooling methods can be different. Just as a reminder, a heat pump by definition can heat and cool. So it has the coils, one set of coils, so outdoor coil, indoor coil, right? Well, a split system has outdoor, indoor. This also has a heat pump in it. It's just in one package. So heat pump just means it can cool and heat depending on the refrigerant flow. So that's a review. And finally, just dampers and diffusers. I've mentioned this a few times, but I just want to key in that there are a number of different types of dampers. Dampers by definition are adjustable, so you can have these things that are kind of more regular. You can have circular dampers. I mean, it really just depends on the application, but a damper is adjustable, whereas a diffuser, generally speaking, is some people sort of mix these terms up, but generally speaking, a diffuser is static, right? So these don't move. These louvers don't move. Whereas with a damper, the whole point is with the damper you can open it and close it, whereas a diffuser is just static, right? So this distributes the air, that was in a previous video where you can have one direction, you can have bidirectional, you can have tridirectional, or you can have one like this, which is really common, which will diffuse the air in all directions, and this will be kind of push it out radially. Okay, well that's it for the discussion of commercial HVAC.